Hi, this is Mrs. Nelson. We're looking at a task from Illustrative Math for 7th grade, Unit 1, Lesson 2, Activity 3, Scaled Triangles. It says here's triangle O, followed by a number of other triangles. And the goal of this is to do some comparisons and try to determine which of those are scaled copies. So I actually took that image over here into Google Slides because I want to be able to use a tool that's called the Polyline tool. So on this toolbar right here, there's a line tool, but if you use that drop-down box, you can choose the Polyline tool. And then you can trace a shape using that Polyline tool. So I'm going to click on each of the vertices. And I've traced that triangle and did as well as I could. There might be a little bit of error with that, but I did pretty well. I'm going to empty the inside so I can see anything underneath it. But I also want to be able to see the outline of it. So I'm going to pick something that hasn't been used yet. Purple hasn't been used yet. I'm going to make it a little darker on the edges so that as I drag it around, I can compare it a little easier. So first thing, my eye goes straight over here to B, and B looks exactly the same to me. So I'm going to just double check that by putting that on top of it, and it's exactly the same shape and size. So those are identical, and so does that mean they're scaled copies? Yeah, actually they do. A scaled copy doesn't have to be larger or smaller. It can be exactly the same size. I noticed that this triangle also has a right angle. So if I'm looking at these other triangles that don't have right angles, it can't be a scaled copy, because there's no way that was just made larger or smaller. It wouldn't have tweaked the angles like that. So I'm going to look just at these right angle or right triangles. And if I match this one up here, I can see that the triangle C is like taller but on one side but shorter on another. So those can't be scaled copies. So C is definitely not a scaled copy. I'll come down here to G, excuse me, not B, G. G looks like it's a little bit taller on the one leg and a little bit longer on the other leg, and by the same amount. Now, with the knowledge that I have right now, yeah, that looks like a scaled copy. I would say that G is most likely a scaled copy for what we have learned so far about scaled copies and how we can show them or make them. E. If I bring this triangle down to match up with E, it's another right triangle. It looks like that I could like double the height and double the length, and it would make this larger triangle. And I can confirm that. If I look at these side lengths right here, this one's 4, twice as big as 4 is 8. This side is 5, twice as big as 5 is 10. This side is 3, twice as big as 6. So yeah, in fact, that is a scaled copy. It has a scale factor of 2. So then I'm going to look at this right triangle right here. And it looks like, when I line those up as well as I can, it looks like that triangle might be half as short and half as wide. So if I compare those numbers, 4 divided by 2 is 2. 5 divided by 2 is 5 divided by 2, or 5 halves. 3 divided by 2 is 3 halves. So yeah, that is a scaled copy. It's half as big. So it's a scaled copy with a scale factor of 1/2. Now let's look at this one right here. You can see it's kind of hard to tell, but it looks like the angles are a little bit different of the triangle. It's not exactly the same shape. Oop, I didn't line that up very well. Not exactly the same shape. That angle seems to go out further with that green triangle underneath. And if I put this triangle here, it looks like that if this were to continue on, it wouldn't go as high up in that triangle. So I don't think H is a scaled copy. So looking at those comparisons and thinking about what we do know so far, I would say that B, it's a scaled copy, is exactly the same size. That I would also say that G is a scaled copy, E is a scaled copy, and so is D. D is a scaled copy. Again, we can look at those side lengths and be more precise. Instead of just eyeballing it, we can actually divide. Or we'll start to grow our capacity and recognize how, just like I saw here, that the angles might play a role as well. Thanks for learning with me.